dun, 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 dun. Yes, it's still Star Wars fever, my friends. Yes, Star Wars. I haven't seen the movie yet, but I'm really gearing up for it now. Right now, I'm really gearing up for another math video. Yes, I know you guys want to do math. Don't lie. Hey, let's get started. We have an objective here. Today's objective is to solve word problems involving the division of whole numbers with answers in the form of fractions or whole numbers. And actually you have already done this, so this should be a cakewalk. Yes. With my doggy friend, let's go ahead and take a look at some key strategies for problem solving. There's something you may want to take a look at. First and foremost, we need to model the problem. Yes, that's what the arrow's pointing to. Model the problem. Yes, you need to model the problem because when you draw a picture, it kind of helps you get started, even though sometimes the problems may be more challenging. Like, can you draw something? And I know you don't see a question mark there, but there's supposed to be one there. There you go. See, you didn't see anything. That's right. Nothing. Okay, it says, what can you draw? Can you draw something? What can you draw? And then finally, what conclusions can you make from your drawing? So if by modeling the problem that you're working on, is there some way you can show a conclusion that such a quantity equals this or whatever the problem may be asking you? Okay? And then next, also another very key strategy for success in problem solving would be to calculate, to solve, and write a statement. So we're basically calculating to solve and write a statement. It may be any kind of response to a question that so many 23 students can eat so much pizza because, and it's a way of showing a better understanding of the problem. And then finally, this is the last key, is to assess the solution for reasonableness. And that basically means that yes, my answer seems reasonable. If you have 3 whole pizzas, right, and you have 20 people eating those 3 pizzas, would it be reasonable that each person would get a whole pizza? Probably not. So you see how that all works. Yeah, okay. Page 2. So here we have a total of 2 yards of fabric is used to make 5 identical pillows. How much fabric is used for each pillow? And by looking at the problem, the first thing, and again, we're always thinking about that read, draw, write, still plays a part in our problem solving. Here we have a total of 2 yards of fabric. It says 5 identical. Identical should make you kind of think equal. So this lets us know we're looking at division. Finally, our question, what we don't know and what we're trying to find out is how much fabric is used for each pillow. This is important by taking out the tape diagram because it starts with that modeling of the problem. So I'm going to go ahead and mark this. If I have a total of 2 yards of fabric, I'm going to put that right up here. And I'm modeling this is all the fabric I have, this whole tape diagram here. If you notice then, we have 5 identical pillows. Basically, I can say, based on this, that this entire thing here is 5 units. I don't normally do this, but I could do this, showing that this is 5 units altogether. And 5 units, of course, is going to equal the 2 yards, because that's the whole thing. I have to be honest, when you think about our problem, doesn't that seem pretty basic? We have that much fabric, we're dividing it up into 5 equal pieces because we want 5 identical pillows. Well, 5 units is equal to 2 yards, then we could say that 1 unit would be equal to actually the 2 yards divided by the 5 equal pieces. And therefore, we look at the problem and we say, well, 2 divided by 5, we already learned. That's 2/5. That's what that is, 2 divided by 5. And this became this little 1 unit that we didn't know. So this lets us know that's exactly what 1 unit would be. 1 unit is 2/5. So each unit here is also 2/5. I could write them into all the boxes, but it will stop right there. So now I can come down and say that each pillow uses the 2/5 and 2/5 yards of fabric. We're going to check for the reasonableness. Let's see if this is reasonable. This is where I might want to say, well, if each unit is 2/5 and I have 5 of those, that's saying 5 times 2/5. And this is going to be equal to, we're not doing multiplication yet, so let's just say, write this 5 times. So if we have 2/5 plus 2/5 plus 2/5 plus 2/5 plus 2/5. Wow, that was a mouthful. That's going to equal, well, the denominators are the same. That's nice. 2, 4, 6, 8, 10 on the top, And then we have our 5 as our denominator. So 10/5, so I was trying to kind of get you to think about it, is 10/5 is equal to 5/5 plus 5/5, right? Isn't that true? And if 10/5 is equal to 5/5, well, then that's like saying that's equal to 1 plus one more 1, which is equal to 2. So you can see that our answer is 2. So here it brings us right back to where we were checking our work for the reasonableness of it. My goodness, that is a lot of yellow. I feel blinded. I really do. Moving on to the next page, here we have problem 2. Now, we have an ice cream shop uses 4 pints of ice cream to make 6 sundaes. And of course, we know the best ice cream in the whole world is Ben & Jerry's, my friend. Yes, Cherry Garcia. Just kidding. That's my favorite ice cream. But let's get back to the problem. An ice cream shop uses 4 pints of ice cream to make 6 sundaes. How many pints of ice cream are used for each sundae? Again, it's always talking about when we're solving these problems is they're always looking at like this total amount. We're trying to make something and there's an equalness about what we're making. And then finally it asks us then how much of that total amount are we using for each item, in this case each sundae. Well, let's just think this out loud for a second. 4 pints of ice cream? Well, with 6 sundaes, you can see that each sundae will not have a pint. We're going to actually have less than 1 pint for each sundae. Now, if we have 4 pints of ice cream, we can again show that hole right there. Here's our 4 pints. Right? Our 4 pints is right here in this hole. Okay? And then we basically need to make 6 sundaes. Well, I'm going to split this right in half because I could say 3 sundaes over here, 3 sundaes over there. So that means if I divide this into thirds and this into thirds, I will have 6. Isn't that nice? Yeah. Okay. And now I'm looking at it. This has been divided into 6 units. Now, it just so happens that 6 units is equal to 4 pints. Okay. Now we need to determine what 1 unit is because that is what the problem is asking us for each sundae. So we come down here and we say that 1 unit then is going to equal that 4 divided by those 6 units, each one of those units. So we get 4 over 6, which is the same as 4 divided by 6. I kind of jumped to that stage, which brings us into that 1 unit right here. 4, 6. And that was kind of sloppy. And each one of those is going to have that same amount, which is where we can go to check our work. So we've modeled the mathematics. And now, we didn't actually write our whole statement here. So to answer the question, 4/6 pint of ice cream is going to be used in each sundae. Ooh, that is very sloppy, Mr. War. I'm going to come over here and I'm going to go ahead and check my work. Does it seem reasonable? Well, if I have 6 sundaes and each sundae uses 4/6 pints, now I have my setup. Now, of course, I'm not multiplying, so I'm just going to go ahead and add all of those 4/6, those single units. I have 6 of those there, same denominator, makes that nice. So this is just 4 times 1, 2, 3, 4, 5, 6. We could do that, right? That would be, that write down, let me see, 6 times 1, 2, 3, 4, 5, 6. And so I have 6 4s. I'm sorry, I thought I counted one more 4. Yep, 6 times 4, which is 24. So that's 24 over 6. Again, we can kind of think of that as the same thing. 6 over 6, right? Because equal to 6 over 6 plus 6 over 6 plus 6 over 6 plus 6 over 6. We have 24, so we have 4 of them. 6, 6, 6, and 6. 4 times 6 is 24. And these happens to be, yeah, that's right, 1 whole for each one of those, giving us 4. Again, bring us all the way back to our initial dividend, our whole part. Okay, so we'll go on to the next page. We're doing problem 3 where it says an ice cream shop uses 6 bananas to make 4 identical sundaes. Now this is unusual because this is different than the last problem that we looked at. You see, here we have more bananas than we have sundaes. But let's go ahead and get our tape diagram out here. Woohoo! And that's 6. And of course that's bananas. That's what this is going to be. This is 6 bananas across. And then right below, that's right, we have our 4 sundaes. Now it's for the dividing part, right? Since we're going to be dividing by 4, we can go ahead and take our tape diagram, break that into fourths, like we've done right there. So we know that 4, and we'll just call them units, even though they're sundaes, 4 units is going to be equal to 6, right? 6 bananas. So we're trying to figure out what 1 unit is, and 1 unit would equal, that's right, 6, that total, divided by 4. 6 divided by 4 then becomes 6 over 4. we have 4 units. We're going to multiply that again by 6 over 4. Okay? Now, we're going to go ahead and take that 6/4 and we're adding those. What a great way to check our work. Are you seeing a pattern? It's really looking easy. Denominator is the same, so we're just taking a 6 times 4, which is 24, over 4. Remember, the 4 just comes right on over. And here, you can see that we can still do, in this case, we want to do fourths. We want to do equal fourths. But we're going to have a lot of them here. To get up to 24, we're going to have 6 of them, right? So we're just going to write them all down, and I'm trying to get them to fit in here. And it looks like I'm going to be short 1. I try to squeeze that 1 here in the end. But we have 6 across here. So now you can see we're going to have 6 as our answer because we have 1, 2, 3, 4, 5, 6 holes. Now let's go ahead and keep moving. We have a lot of problems to do, so I want to kind of keep the pace. They're going to get a little bit more challenging as we move along. It says Julian has to read 4 articles for school. He has 8 nights to read them. He decides to read the same number of articles each night. Of course, that makes it division. It says how many articles will he have to read per night? Okay, and then what fraction of the reading assignment will he read each night? And he has 8 nights to read them. Now we split that up into 8 nights. It says he decides to read the same number of articles each night. Okay, well, if he had 4 nights, he'd read 1 article per night, but since he has 8 nights, that means he's going to kind of like read less than that, right? Half of an article. So let's go ahead and write our 8 units. We tend to write the units, right? It's going to equal the 4 articles. And then here we have 1 unit then is going to equal the 4 articles divided by the 8 nights that he has, which is going to equal 4/8 articles. And that's basically our statement right there, that Julian will have read or will read 4/8 articles per night. But the second question is unusual because it says what fraction of the reading assignment. That's interesting because it's the reading assignment is 4 articles. Since he's reading for 8 nights, he's actually of that assignment, he's just reading 1/8 of his total assignment each night. So the 4 doesn't play the role here because the 4 is just going to equal the assignment. The assignment is to read that. And the assignment is to read the 4 articles. So if you want to think of the assignment as 1 whole, we have the 8 nights then multiplied by the 4/8, which was basically the how much he was going to read per night. Again, we're going to do the same thing, 4/8 plus 4/8. And I'm going to go all the way across here. I'm going to save a little bit of time. As you can see, 4/8 plus 4/8 plus 4/8 plus 4/8. I'm going to do that 8 times. Well, if you do that 8 times, you're taking the 4 and you're adding those all together. What do you end up with? 4 times the 8 of them. Isn't that going to be 32? And then 32 divided by your 8 gets you right back to 4, okay, which was the 4 articles. He must read at least 4/8, right, of an article each night, but of the assignment, it would have been 1/8 of the assignment. As always, my friends, live long and prosper.